Okay, so here's a problem. I ask you that I tell you I've got a mixture of this and this, and I want you to separate the two molecules. Come up with a way that these two molecules could be separated using an acid-base separation. So what you want to have happen is one goes into the water layer, the other one goes into the organic layer, and as a result you've separated the two molecules. So what do you think about that? You like acid-base chemistry? To get something to go into the water layer, what does it have to have? It's got to be charged. Okay? So what I'd like you to do is I'd like you to think about, and talk to the person sitting next to you, at what pH will this molecule be charged? At what pH will this molecule be charged? And then at what pH will this molecule be neutral? And let me know what you think the answer is. So talk about it with the person sitting next to you. What pH will it be charged? What pH will it be neutral? Because if it's charged, it will be in the water layer. If it's neutral, it will be in the organic layer. And then you can talk about the other one if you finish with the first one. So if it helps you, here's the titration curve, what the titration curve looks like. It's titrating an acid with sodium hydroxide. Okay. So what pH is this going to be soluble in water? What pH will this molecule be soluble in an organic solvent? So Joe has the answer to this one. Joe says pH 5. At pH 5, this molecule will be soluble in organic solvents. What do you think about that answer? No? Why? No? Why not?
It's considered the buffer zone, right?
Yeah, it's the buffer. So what's happening at the buffer? At the buffer point, you've got equal amounts of the acid and its conjugate base, right? 50-50 mixture of the molecule with the proton, the molecule without the proton. Is that the pH you'd want to be at? No, you want to separate these things. You don't just want to have half of it in the water layer. The charged portion would be in the water layer. The other half would be in the aqueous layer. So what pH would that molecule become water soluble?
6 or 7.
Is that?
Greater pH than 5.
Greater pH than 5, even better yet, bigger than 6. Because if you're 1 pKa unit away, then you have like a 10-to-1 ratio of the two molecules. So this one will be water soluble above pH 6. Is everybody okay with that? pH 6, is that on the basic side or the acidic side of the pKa? It's the basic side of the pKa. And what does that mean will be present in the reaction mixture if you're on the basic side of the pKa? The basic form of the molecule. That's true in the titration curve. Whenever we are on that side of the pKa, this region, pH is greater than pKa. We are mostly in our conjugate base form, A minus. At any pH less than our pKa, we're going to be in the acid form, HA. We're going to be here in our basic form. Everybody okay with that? All right, now the next one. When will this, at what pH values will this molecule be soluble in organic solvents? Less than 10.5. Soluble in organic solvents.
Greater than 11.5.
Okay, why greater than 11.5? You're right, Michael.
Because that's, because essentially you wouldn't have, the acidic form is NH3.
So the conjugate acid here might be good to draw what it looks like. Water soluble or organic soluble? Water soluble. Where will this exist? Well below 10.5. Where will this exist? Well above 10.5. So above 11.5 is a good value. So I can ask you in a problem like this, at what pH will this molecule be soluble in organic solvents? Not even asking you to try to separate them. I could ask you, at what pH would it be soluble in organic solvents? And you would say, well, at a pH greater than 10.5. And then I'd ask you why. What would your answer be? At pH greater than 10.5. That's on the basic side of the pKa.
You mean nitrogen, the positive charge to be soluble?
If we are on the basic side of this pKa, this would give up its hydrogen, and it would look like that. And at that pH value, this is soluble in what? Organic solvents. So if I asked you, at what pH will this be soluble in water? You would say what? Anything below 10.5, especially below 9.5, and why? Because at pH less than 9.5, this molecule exists in its acidic form, the conjugate acid form, which is charged, and as a result it will be soluble in water. Are you okay with that? All right, so now I've made it a little bit more difficult. How do you separate these two? What would you do to get them separate? What do you think, Michael?
Go to pH 4.
So if I go to pH 4, what will this be? How will this look? Same. Okay, and it will be soluble in what? Organic. At pH 4, what will this be? How will this look at pH 4? Charged, and it will be soluble in water. Hey, you got a separation. We take the mixture of these two, we add in pH 4 water, shake, 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 add an organic solvent. This guy is in the water layer, this guy is in the organic. No, back up. At pH 4, this guy is in the organic layer, this guy is in the water layer, and we've separated the two of them. What's another pH value that we could get them separated? David?
Greater than 11.5.
Okay, so above 11.5, why would that be another pH value where we could separate the two of them?
Benzoic acid will deprotonate.
At pH 11.5 and above, this molecule will exist in its conjugate base form, which is soluble in water. At pH above 11.5, this molecule will exist in its basic form, which is going to be soluble in organic solvents. And so this is in the organic layer, this one is in the aqueous layer. So you see, we could do it two different ways here to separate the two molecules. Is that okay? Oh, so you had asked about that one, right? Okay, is that okay?
Yeah.
Okay. So just don't get yourself messed up. Acid side of the pKa, acid form. Basic side of the pKa, basic form. It's really not any more difficult than that. Then you just have to keep track of what will the basic form look like? What will the acid form look like? Is it water soluble? Is it not water soluble? Well, that depends upon the functional group. Okay? So are you okay with that kind of an explanation problem? Separation? Okay, so got this one nailed?